Hello there, this is Mike with a brief video about dealing with binomial probabilities, which are part of the probabilities unit here in the course and often give people trouble. So I wanted to give you some advice about working with binomial probabilities and look at a couple of examples. So first, the bad news. You need to understand and use basic probability. So that's an important thing to keep in mind. For those of you that feel comfortable with probability generally, that's not bad news at all. But sometimes people really struggle with fundamental probability rules, and that's going to continue to be important here. So the previous work you've done, still important, and you're going to use it when working with these binomial probability problems. And because those basic probability problems can be difficult sometimes, the binomial distribution doesn't make it any easier because it adds a little bit of complexity to the problem. The good news though, you still don't have to be a genius to work on probability problems, even binomial probability problems. In fact, with binomial probabilities, you get some extra tools at your disposal. So, using some basic rules, like before, and your common sense, you can still get pretty far with these problems. It's important to continue to use language before you deal with the numbers. The calculations, you're going to use technology to help you complete, and the important thing is to know what to tell the technology to do. And again, I'll show you some examples, and I hope you'll pay attention to examples in other videos or in other contexts in which there's an attempt to rewrite the probability statement in a number of different ways before inputting any numbers into any calculating device. Dealing with the numbers comes after you know what to do with them. And like I said, using some kind of calculator, handheld calculator is okay, but I'm encouraging you throughout this course to use a spreadsheet. That's likely to be the kind of software that you'll be using if you ever do statistics outside of a class like this. In some cases, you'll be using software like SPSS or SAS or maybe even R. But spreadsheets are relatively easy to get started with and are a good way to get into the use of technology. So just a few things to remember about probability distributions. First, they're a list of all the possible values that a random variable can take on and the associated probability with each one. Remember, a random variable is just a measurement of an outcome. So for example, if you roll a die, the random variable might be the number that appears on the top of the die when you roll it. When you add up all of the possible outcomes, their probabilities should sum to 1. And as before, and this is true all the time, probabilities always need to be between 0 and 1. Binomial distributions have all of these properties, but they also have some special extra properties that make them binomial distributions. Each individual event has 2 outcomes. There are a fixed number of trials. The trials are independent of one another, and the probability of a success or a failure remains constant. It's important to keep in mind that the use of the terms success and failure just refer to the 2 different outcomes. Sometimes success will refer to something that does not seem like a success at all. But we're just using those terms to clarify the difference between one outcome and another. So here's an example. This is one that people have struggled with on the assignment in previous courses. So if this is something that you have difficulty with, this might explain how to deal with a similar situation. So you have an airline that books more people on the plane than there are seats. This is actually a common practice. Even on big airlines, they book more people than can fit on the plane because people tend not to show up, or at least not all of the people usually show up. Something comes up in their lives, they are late, they decide not to come, or they change their flight. And so overbooking is a common thing to do. We're using a small airplane here to keep the numbers relatively easy. And if we book 16 people on an airplane that only seats 14, what's the probability that not enough seats will be available? So notice that I'm writing this probability down here literally as it's been stated in the problem. So the probability that not enough seats are available. And if you think carefully about what that means, all that really means is that because there are 14 people, 14 seats on the plane, then that means that if 15 or 16 passengers show up, then there won't be enough seats. If only 8 people show up, or even if 14 people show up, then there will be enough seats. The only reason there would not be enough seats is if more than the number of seats on the plane appear. So again, I'm just writing this out in English. Okay, so there's an or there, which using a basic probability rule says if there's an or, then I can add the probabilities individually together and then subtract off the places or the probability that both would happen at the same time. Now keep in mind that you can't have both 15 passengers and 16 passengers show up at the same time for the same flight. Either one of them happens or the other one happens, and not both. So we can actually forget that piece of the calculation. And now each one of these, getting 15 passengers out of 16 people, is a binomial distribution. There are two outcomes. They either show up or they don't. The probability is constant. There's an 85% chance or a 0.85 chance that someone will appear or not. And the probabilities remain constant. We know that the probability is 0.85%, and the events are independent of one another. So each one of these is a binomial calculation, a binomial distribution calculation, and in Excel, using the instructions that hopefully you've seen in other videos. This is the command that you would type in. In some cases there might be a binom .dist, for example, in Excel. But you would type in this command into a spreadsheet, and you could type in this other command into the spreadsheet, add them together, and you would get 0.283901. So notice here at the end of the problem, I haven't typed in any numbers, I haven't dealt with any real math, if you like, until the very end. And that's important to pay attention to. If you start typing in numbers at the beginning before you know what to type in, you'll frequently find the wrong thing. So I want to continue with this example because there's another way to look at the problem. You can start out in the same place, that not enough seats being available means the same thing as 15 or 16 passengers show up. But another way to say 15 or 16 is to say at least 15. This is a common phrase in probability. If you say at least 15, well, that's a clue that maybe using complements would be useful. And so one way we can think about this is to say, well, instead of at least 15, we can say 1 minus the probability that 14 or fewer passengers appear. And this also is a binomial distribution calculation. The difference, though, is that in the spreadsheet command, the 1 at the very end stands for whether or not you're computing a cumulative probability. And in a cumulative probability, we're adding up all of the possible probabilities from 0 up to this number. And that's exactly what this phrase means, 14 or fewer passengers appear. And this calculation is what the spreadsheet will do if you type in a 1 or true at the end of the command. And when you do this in Excel, you get the exact same result as we got in the previous calculation. Here's one more example. Suppose that someone has learned that a company to which they applied has only hired 2 women among its last 20 new hires. She learns that the pool of applicants is large and has approximately the same number of qualified men and women. So what's the probability that when 20 people are hired, 2 or few of them are women? So again, I'm going to write this in terms of English words. The probability that 2 or fewer means the same thing as 0 or 1 or 2. And because those ors are mutually exclusive, that is, there is no overlap, you can't hire no women and 2 women at the same time, then I can just add them together. Each one of those is a binomial distribution calculation, and so you'll notice if there's an equal number of qualified men and women, the probability of choosing a woman is 50%. There are 20 people hired, and the question is, what is the probability that 0 are hired, or 1 is hired, or 2 are hired? And that's the calculation that you get when you type those commands into a spreadsheet. Or you could do this a little bit differently. Again, instead of adding each individual probability up separately, you could do a cumulative calculation. So notice these all ended with zeros, saying that they were finding the exact number of successes. But if we do a cumulative calculation down here, we're going to go from 0 all the way up to 2 and add those together, and you'll get the exact same calculation. Notice that the probability from before was very low. It was very low, 0.0002. In other words, if there were no discrimination in this company's hiring process, although this outcome is possible, it's very unlikely for it to happen that 2 or fewer women would be hired. When an event has a low probability and that event actually occurs in statistics, that often causes us to question our assumptions. So imagine somebody tells you that tomorrow there is a very, very low chance of rain. And you're going to assume, based on that information, that it's probably not going to rain. Well, if it does, then you're going to look back and say, well, maybe there was something wrong with the way that person decided what the chances of rain were. So if something that has a very low probability actually happens, we start to question our assumptions. So in this case, our assumption that there is no discrimination might be wrong. That's one of the reasons we use probability, is to test assumptions. And here's a rule of thumb to keep in mind. Probabilities of 5% or less are generally considered low probabilities. And so an event with such a probability, 5% or less, if that event actually occurs, then we consider that to be an unusual outcome. That's something to keep in mind as you go forward in the course. So here's a brief summary. So like other probability problems, remember that numbers shouldn't come into play until the end of the process, and once you're there, you just plug them into a spreadsheet. Try to think through the original probability statement to see if probability rules will apply, like addition rule or the multiplication rule or the use of complements. Like before, you want to pay attention to language that involves the phrase at least. And throughout all problems involving binomial probabilities, you should notice that they all end in using that binom dist command. So there's a lot of commonality to these questions. The trick, if you want to call it a trick, is that you have to figure out what the numbers are that you are supposed to plug into that command. You have to figure out what numbers to tell the computer to compute with. And if you understand why those numbers are what they are, then you'll be ready for any problem that they throw at you, including those that you might see on the exam. I wish you good luck.